Hello everyone. I wanted to give you a recap of some of the recent activities in the Quantum ATK team. And today I'm going to focus mostly on some new initiatives that we've been working on. So, setting the frame. Quantum mechanics is probably the most precise theory known to us humans yet. Density functional theory is then the most practical approach to simulating quantum mechanics for technology applications. Even though the equation seems maybe daunting, in essence, this is what we are doing on a daily life. The point is that DFT is constantly becoming more predictive. And that could be kind of strange at first, but it's still the same fundamental equations more than 50 years ago. So there's mainly two driving factors behind that it has become more predictive, even though the theory is the same. Newer algorithms and faster CPUs have pushed the boundaries of the system size we can simulate. And in addition to this, we now have much more better experiments that reveal the complexity about the atomic scales. Putting those two things together, we actually have a much better understanding on how the reality looks like. And when we use this reality in our simulations, DFT actually comes out to be ever more predictive. So the question is, taking this trend, how do we then maximize the impact that we now see that DFT is becoming more predictive? The point is here, atomic scale modeling will be an essential component for many future technologies. It is what is going to revolutionize material research, and that is independent whatever it's for chip design or whatever it's to help global warming, or you imagine. And what we are focusing on, and which I'll give you some update on, is that we're using AI. Synopsys will provide quantum mechanics in linear time, and this is a key component for our partners and customers to have a success. Quantum mechanics in linear time, I could talk about this for a long time, but now I'll tell you everything you need to know in 90 seconds or less. It's all about time, the 3 T's. Time to generate training data, time to train, time consumption, and usage. While quantum mechanics in linear time is not a new attempt in this field, it is kind of old. The traditional approach was, instead of doing quantum mechanics, let's do classical physics. So instead of calculating the quantum mechanical system, we would create a system of springs, as depicted here. And these springs could be super advanced, super complicated. Despite being fast, the precision is not the needed quantum mechanical precision, and hence it's not so predictive as you want. And it's almost impossible to use for unsupervised learning. And then sadly, it's biased by our presumption. So it's a good thing for solving things that we already understand and already know. So over the last many years, there's been several attempts to improve this. And then, most importantly, you can say neural network was attempted because it was inspired by the most powerful computer that we know, our own brain. The idea behind neural network is to mimic the brain. However, there is a weakness, and it's a fundamental one. And it is in the inspiration of the human brain. The human brain is evolved to process massive amount of information to perform identification and categorizations. In essence, quantum mechanics is not a categorization problem. So, even though it's a very impressive machinery and it can do many things, it is not well suited for what we know. And as a reference, you can say the human eye is about 600 megapixels. And one can debate what is the frame rate of the human eye and our processing power. But nevertheless, our eye processes more than a terabyte of data per day, and look how long it takes us humans to identify different objects. So neural network is not going to be the solution. A very promising technology that we possess is called moment tensor potentials. And it is a systematically improvable inter-atomic potential class The strength of this is that this is based on mathematics, and it's in that sense, it's mathematical, it's analytical, it's unbiased, and it's fast. And why is this a superior technology to neural networks? Quantum mechanics is the mathematical and analytic understanding of the reality. So hence it is the natural language of quantum mechanics. On top of that, it is unrivaled in time to solution. The time it takes to generate the needed training data, the time it takes to train, and the time it takes to use. So in short, in 90 seconds, that is why Synopsys moment tensor potential technology is the best technology to be using. Quantum ATK offers a unique integrated completed solution. And what we are working on together with customers is application-specific smart generation of training data that leads to successful products. While the application area of linear quantum mechanics is many-folded, these are just 6 highlights that we are currently engaged with. This could be for the simulation of amorphous materials, structure generation. It could be gate stack engineering of complex gate stack materials, or it could be phase change alloys for PCR structures, thermal transport in monolayers, hafnium chloride deposition on surfaces. Thank you very much.